Permanent magnetic moving coil PMMC permanent magnetic moving coil or PMMC instrument. PMMC instrument here definition is define PMM is the instrument which is used the permanent magnet for creating a stationary magnetic fields in between which the coil moves is known as the permanent magnetic moving coil or PMMC instrument. The definition is instrument acting as a permanent magnet creating a stationary magnetic fields in between which the coil moves is known as a permanent magnetic moving coil or PMMC instrument. It operates on the principle that the torque is extracted on the moving coil. Principle that the torque is extracted on the moving coil placed in the field of permanent magnet. Field of the permanent magnet. The PMMC instrument gives the accurate result for DC measurements. This is the measurement of DC measurements. It is accurate of the DC measurements. And how to construction of PMMC. Next slide is PMMC principle to take the permanent magnet and insert a conductor is rotating to the magnetic fluxes. Rotate to the magnetic fluxes are linked to the coil. Then the current will be induced to the coil. Current will be induced in the coil. Then to produce the sinusoidal signal to creating the voltage to creating the sinusoidal signal instantaneous voltage. Construction of PMMC instrument. Construction of PMMC permanent magnetic moving coil instrument. The moving coil and permanent magnets are the main part of the PMMC instrument. The moving coil and permanent magnets are in the main part of the PMMC permanent magnetic moving coil instrument. The part of the PMMC instrument are explained given below. The explanation of the PMMC here. The block diagram of construction of PMMC as shown in the basic diagram. As shown in the diagram. Here permanent magnet moving coil instrument. Permanent magnet moving coil instrument. Permanent magnet moving coil instrument. The north pole, we have to fix the north pole and south pole and take the coil north pole and south pole and take the core coil and permanent magnet and north pole coil are formed in this coil is called as the coil and former and put in the needle and take this coil and take this reading and take it will be a reading scale, a linear scale. It produces a linear scale and permanent magnet and coil and former radio fields and moving coil will be moves and producing the balancing. Here below we have to take the controlling of the balancing weight and this coil balancing weight and providing the spring providing the spin, and this having a mechanical construction, and it will be provided a mechanical construction and electronic mechanical setup, and coils and pivot and jewel on the above, and spring will be taken and balancing of weight, and take this pointer to point out this, and take the scale and mirror onto the device, and permanent magnet and pivot and jewel bearing, pivot and permanent magnetic moving coil, permanent magnetic moving coil instrument. Radially it will be rotated. Circular radial means a single point will be rotated circularly, is called as a radial field. For example, when the constant water, when you have to thrown onto the stone, they have to produce the waves. That is the radial fields. And pivot and jewel bearing springs. This is the basic construction of a North Pole and South Pole, and in between this core is a permanent magnet. This is the basically block diagram and construction of permanent magnet. This will be produced by uh, Arson scientist is introducing the Pmmc. Permanent magnetic moving coil. Here we have to first block is north block and south block. It is a magnet attracted to the various materials, to balancing the, when you have to rotate, you have to producing the weight for balancing of the equipment. Springs also protection for this equipment, and pivot and jewel bearing, balancing weight. Permanent magnetic moving coil and pivot will be placed onto this, and jewel and bearing. Then we have to go to the next slide. The coil is rotating constant speed. The coil is the current carrying part of the instrument, which are freely moved between the stationary fields of the permanent magnet. The coil is the current carrying part of the instrument, which is freely moved between the stationary fields of the permanent magnet. The current passes through the coil. 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 Current passes through the coil. The coil is the current carrying part of the instrument, which is freely moved between the stationary fields of permanent magnet. The current passes through the coil deflects it, due to which the magnitude of the current or voltages are determined. The magnitude of the current and voltages are determined, and the coil is mounted onto the rectangular former. It will be produces a rectangular former which is made up of aluminum. The rectangular is made up of aluminum rectangular. The coil is mounted onto the rectangular former, and which is made up of aluminum. The former increases the radial and uniformly magnetic fields. The former increases the radially it will be rotate and uniform magnetic fields between the air gap of the poles. The former increases the radially it will be rotate and uniformly magnetic fields in between the air gap. There is a space between the magnetic coil and permanent magnet and coil and a gap between these poles. The coil is wounded with a silk cover copper wire between the poles of magnet. The coil is wounded with the coil with the coil with the coil the coil is wounded with the silk cover copper wire between the poles of magnet. And next slide of this PMMC, the coil is mounted. The coil is mounted on a rectangular former which is made up of aluminum. This will be constructed by manufacturing with the material is aluminum. The former increases to the radial and uniform magnetic field in between the air gap of the poles. Then you have to rotate the coil, the uniformly magnetic fields in between the air gap of the poles. The coil is wounded with the silk cover copper wire between the poles of magnet. The coil is wounded with the silk cover copper wire between the poles of magnet. Then you have to construct this magnetic system. The PMMC instrument, PMMC magnet system. The PMMC ఆ మరాఠీ చిన్నప్పుడు గురించి కాకపోతే రిసిపి PMMC magnetic system, the PMMC permanent magnetic moving PMMC instrument, PMMC permanent magnet moving coil instrument using the permanent magnet for creating the stationary magnet. Stationary means stable magnets, and this will be Alnico materials. It will be manufactured by this material is Alcomax and Alnico materials. Alcomax and Alnico materials are used for creating the permanent magnet. Because of this magnet has this magnet has high coercive forces and coercive forces changes the magnetization properties. The coercive force changes the magnetization property of the magnet. Also the magnet has a high field intensity. Magnet is voice recorder. The magnetic has a high field intensity. Magnetic field high intensity. Magnetic field intensity, high field intensity. The basically magnets are manufactured with the material is all maxo material and all nico materials are used for creating a permanent magnet are creating the permanent magnet. And next slide is permanent magnet. And next one is controlling of the PMMC. Controlling of PMMC. Controlling of PMMC. PMMC magnetic moving coil. PMMC. PMMC controlling in PMMC. Controlling the PMMC instrument, controlling the torque is because of the spring. PMMC instrument, the controlling torque is because of the springs. The springs are made up of phosphorus branch. Are made up of springs are made up of phosphorus branch and placed between the two jewel bearing. Their two bearings are at a top level and bottom level, bearing to controlling the speed and balancing of the instruments. The spring also provides the path to the lead. The spring also provides the path to the leading. Spring also provides the path spring are made up of phosphorus branch and placed between the two jewels bearing. The PMMC instrument controlling the torque is because of the spring. The springs are made up of phosphorus branch and placed between the two jewels bearings. The spring also provides the path to the lead. The spring also provides the path to the lead current to flow in and out of the moving coil. Springs are controlling and current is also moving to passes through the wire. The controlling torque is mainly because of the suspension of the ribbon. The controlling torque is mainly because of the suspension of the ribbon. The controlling of this PMMC instrument PMMC phosphorus branch and manufacturing this instrument phosphorus controlling the instrument Controlling Pmmc instrument, the controlling torque is because of the springs are made up of a phosphorus bronze and placed between the two jewel bearings. The springs also provide the path to the lead and current to the flow of in and out of the moving coil. The controlling torque is mainly because of the suspension of the ribbon. Then next slide controlling next is controlling and damping. 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 The damping torque is used for keeping the instrument. Damping torque is used for keeping the momentum of the coil in the rest. Damping torque is used for keeping the moment of the coil in rest. The damping torque is included because of the momentum of the aluminum core which moving between the poles of the permanent magnet. The damping torque is used for keeping the damping torque is used for keeping the momentum of the coil in rest. This damping torque is induced because of the momentum of the aluminum core which is moving between the poles of the permanent magnet. The damping will be produced in the permanent coil. Next slide is moving the pointer. Pointer will be provided. Pointer is moves next the pointer will be point out the pointer and scale. The pointer is linked with the moving coil. The pointer is linked with the moving coil. The pointer notice out deflection of the coil and the magnitude of their deviation is shown on the scale. The pointer notice the deflection of the coil and the magnitude of their deviation is shown on the scale. The pointer is made up of the lightweight material. The pointer is made of the lightweight materials, and hence it is easily to deflected with the momentum. Of the coil. Hence it is easily deflected with the momentum of the coil. Sometimes the parallax error occurs in the instrument. there is a fluctuations in the voltages are high or low or mixing parallax one by one parallelly it will errors will be occur that called as sometimes the parallax error occurs in the instrument which is easily reduced by currently aligning the blades of the pointer. Sometimes the parallax error occurs in the instrument which is easily reduced by currently aligning the blades of the pointer. Then next slide is deflection torque. Deflecting torque induced because of the momentum of the coil. Deflecting torque induced because of the momentum of the coil. The deflecting torque is expressed by the equation shown below. Is deflection torque Td is equal to n is equal to number of turns, d is the magnetic flux density, L is the length of the coil, is rate of change of current, di is the rate of change of current. Di is nothing but a rate of change of current that produces the torque, deflection torque. In the rotation of the coil, they produces the force. That force is called as the torque force. That force is called as the torque force. Where n is the number of turns of the coil, b is produces the magnetic flux density in the air gap. Flux density, d is the flux density in the air gap. D is the vertical horizontal length of the side. D is the horizontal and vertical length of the side. Therefore, I is the current through the coil. How much current produced in the coil? That is the expression for a deflection torque induced because of the momentum of the coil. Deflecting torque is expressed by the equation given below. Td is equal to n into b into L into d into I, where n is the number of turns of the coil, b is the flux density in the air gap, d is the vertical horizontal length of the side, I is the current through the coil. And the next slide is here next slide G is produces G is the n into b into L into the equation 2. Next one is equal to spring provides the restoring torque. Spring provides the restoring torque to the moving coil, which is expressed as torque. Spring provides the restoring torque to the moving coil, which is expressed as controlling torque. Tc is equal to K into theta. K is the constant, T is the angular velocity of the coil, that is the controlling torque. Then we have to go to the next slide. Therefore, K is the spring constant. K is the spring constant. For final deflection, Td is equal to Tc. For final deflection, For final deflection, is time division controlling of deflection, and C is the controlling. Substituting the value of equation 1 and 3, we get K is equal to controlling torque K T theta is equal to G into I. Their angular velocity, and G is equal to I. Therefore, next slide is I is equal directly proportional. Find out this current I is equal to K into theta by G. The above equation shows that the deflection torque is directly proportional to the current passing through the coil. The above equation shows that the deflection torque is directly proportional to the current passing through the coil. The equation I is equal to K into theta controlling torque, and controlling torque is directly proportional to the current passing through the coil. Error in Pmmc. Current error in Pmmc, permanent magnetic moving coil instruments. In Pmmc instruments of error occurs because of the aging and the temperature effect of the instrument. The magnet and spring and moving coil are the main part of the instrument. Permanent magnet and spring. The moving coil are the main part of the instrument which cause the error. The different types of errors of the instrument are explained below. Then we have to magnet. The heat and vibration reduces the lifespan of the permanent magnet, and the treatment is also reduces the magnetism of the magnet. The magnetism is properly for attraction and repulsion of the magnet. The weakness of the magnet decreases the deflection of the coil. Spring is providing the spring. Spring is a weakness of the spring, increases weakness of the spring. Weakness of the spring increases deflection of the moving coil between the permanent magnet. So even for the small value of current, the coil shows large deflection. The spring gets weakened because of the effect of the temperature and 1 degree rises. Every 1 degree or changes or increases in the temperature reduces to 0.004 percent of lifetime of the spring. Moving coil. The error exists in the coil. When there is range in the extended from the given limit by the use of the shunt. The error occurs because of the changes in the coil of the resistance on the shunt resistance, and this happens because of the coil is made up of the coil is made up of coil, hence because of the coil is made up of copper wire which has a high shunt resistance, and shunt wire made up of a manganese as low resistance. And next slide is advantages of PMMC. Advantages of PMMC. The following advantage of PMMC instrument: the scale of the PMMC instrument is correctly divided, and equally uniformly the scale reading will be there, and power consumption of the device is very less power. The power consumption of the device is very less, and PMMC instrument have high accuracy. The PMMC instruments have high accuracy because of the high torque weight ratio. The PMMC instruments have high accuracy because of the high torque weighted ratio. The single devices measure the different ranges of voltages current. The devices will be measuring the instrument. We can measure the voltage and current. This can be done by the use of multipliers and shunt circuit. It can be used for multiplier circuits and shunts. The PMMC instrument uses self-shielding magnet which is useful for the aerospace applications. PMMC instrument uses self-shielding and magnet which is useful for the aerospace applications. Next disadvantages of PMMC instruments. The following disadvantages of PMMC instruments: PMMC instruments are only used for the direct current. PMMC instruments are only used for direct current. The alternating current varies with the time. The rapid variations of the current varies torque of the coil, but the pointer can be noted. The pointer cannot be follow the fast reversal of deflection of the torque. Thus it cannot be used for the AC measurements. It is only for measurement of DC current, not measuring the AC current. The cost of PMMC instrument is much higher as compared to the moving coil instrument, and the moving coil itself provides the electromagnetic damping forces. The electromagnetic damping opposes the motion of the coil, which is because of the reaction of the eddy current and magnetic fields. PMMC PMMC, 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 PMMC instrument. PMMC define a permanent magnetic moving coil. PMMC define PMMC is the instrument which is uses the permanent magnet instrument which is uses the permanent magnet for creating the stationary magnetic field between the fields moving is known as permanent magnet moving coil. PMMC instrument, it operates on the principle that torque is extracted on the moving coil and in a permanent moving coil. And PMMC instrument, it operates the principle of the torque is extracted on the moving coil placed in the field of permanent magnet. The moving instrument gives accurate and a result for DC measurements. The current, the moving coil permanent magnet, moving coil magnets are the main part of the PMMC instrument. The part of the PMMC instrument explained below. The explained below: North Pole and South Pole core coil. The basic construction of this North Pole, South Pole coil and moving coil, and permanent North Pole and South Pole and moving coil rotate, and there is a linear scale. And North Pole and South Pole core, it having the scale is uniformly readings, and pivot and formally scale North Pole and South Pole, and when the coil is moving and magnetic fields are cut to the conductor to produce the EMF, electromagnetic force, that will be deflected onto the coil, that will be indicating the readings in the indicating in the readings in the coil. That will be reading and pointer will be point out, measuring the readings onto the linear scale, uniform scale. And then we have to coil is the current carrying part of the instrument, which is freely moved between the stationary fields of the permanent magnet. The current passes through the coil deflected due to which is the magnitude of the current and voltage are determined. The coil is mounted on the rectangular former, which is made up of aluminum. The former increases the radial and uniform magnetic fields between the air gap of the poles. The coil unit is cover wire between the poles of the magnet. And this is the way we have to coils are mounted on a rectangular former, which is made up of aluminum, for increasing the radial and uniform magnetic fields between the air gap of the poles. The coil is wounded a silk cover copper wire between the poles of the magnet. Poles of the magnet.